Good evening, everybody, and welcome to the Audio Guide to the Galaxy, Episode 1, brought to you by Scitech. My name is Leon, and I am a presenter here at the Scitech Planetarium, and I'm going to be taking you on a night sky adventure, the first of many that me and my planetarium friends will be bringing you over the coming weeks. This recording is timed to take place at 7:30 PM on Saturday, April 4th. Now obviously we've recorded this a little earlier, so I don't know if it's cloudy outside or not, but the weather report indicates that it should be a mostly clear sky. If it is cloudy, don't panic, the night sky changes, but not that quickly. You can certainly take this recording out tomorrow night or the night after. Most of it will be pretty accurate for the next couple of weeks, except for the parts where we talk about the moon. That does change noticeably every day. Firstly, just to double check, you are outside right now, aren't you? If not, then get to it. It's very difficult to look at the sky if you're not looking at it. I would recommend that you wear a long sleeve shirt, long pants and enclosed shoes. Stargazing gets surprisingly chilly, even in warmer weather. You might also want to put on a bit of mosquito repellent as well. All ready? Excellent. Let's get stargazing. Tonight we've got a few things on our agenda. We're going to be looking at a planet, a very famous constellation, and the moon. And we're going to go into a bit of detail about some of the things that you might not know about these. I think we should start by looking for a planet. Let's live a little, you know. The planet we're looking for tonight is... I'll tell you in a moment. Firstly, we need to be facing the right direction, and that direction is the northwest, and we need to have a good view of the horizon. Now, depending on the layout of your property, you might need to go out onto the front lawn to get a better view, or even climb onto the roof of your house. I live at the top of a hill, so I have a beautiful view of the western horizon, not so much the eastern sky. All I can see is my neighbour's fence. However you do it, make sure you're facing northwest and can see the horizon. But which way is northwest, I hear you cry? There are many ways of getting your bearings using the stars, and we're going to cover some of those in later episodes of this audio guide. But for now, it's simple. The sun rises in the east, moves across the sky, and sets in the west. Now obviously it's currently nighttime. I'm not expecting you to watch the sun set, but I do expect you to know which direction the sun sets, roughly, relative to your house. And look in that direction. Congratulations, you're facing west. Behind you is east, to your left is south, and to your right is north. So now that we're facing west, to face northwest, all you need to do is turn a little bit towards your right, and now we're facing the right direction. Look out into the northwestern sky, somewhat close to the horizon, and see what you can spot. You should be seeing something interesting out there. If you need a hand, then quite literally, hold your arm out at full extension and spread the fingers of your hand out. And about a hand span above the horizon, you'll see a very bright object, kind of yellowish, almost whitish even. It's not hard to spot. It's literally the brightest thing you'll see out there in that part of the sky at this time of this evening. So if you're currently looking at a big bright object in the northwestern sky, thinking to yourself, am I looking at the right thing? I can assure you, you definitely are. And as you might have guessed, this object is not a star. It is a planet. This planet is made of rock. It's almost as big as the Earth, just a tiny bit smaller, and it has a very thick atmosphere. Have you figured it out yet? If you guessed Venus, congratulations. You are correct. Named after the Roman goddess of love. So named because it shines so brightly in our sky, just like the fires of passion that love ignites in our hearts. Venus is so bright in our sky because of a combination of several different things. Firstly, it's reasonably close to the Earth, being the next planet into the Sun from us. Next, because it's closer to the Sun than us, it receives more sunlight than we do. And third, the clouds in Venus's atmosphere are very good at reflecting a lot of that extra sunlight back out away from the planet. And all these things combined make this planet glow so brightly in our night sky. In fact, Venus appears to be brighter than any of the stars in our night sky. I want to be clear on that sentence, appears to be brighter. Fundamentally, the stars are brighter because they produce their own light and they shine on their own, whereas Venus just reflects sunlight. But the stars are so far away that, by comparison, Venus appears brighter than any one of them when we look up in our night sky. And this difference between what appears to be bright and what is actually bright is a very important topic in astronomy. Another interesting thing about Venus is that because it's closer to the Sun than the Earth, whenever we're looking at Venus, we're going to be looking pretty close to the Sun as well. And this means that we only ever see Venus just after sunset or just before sunrise. You will never ever see Venus at midnight, no matter how hard you try. So for this reason, Venus is sometimes nicknamed the evening star or the morning star, depending on when you see it. But don't let the name fool you, it's definitely a planet. But for as beautiful as Venus looks in our sky, it's not a very pleasant place to live. We mentioned those clouds in the planet's atmosphere that reflect all of that sunlight. Those clouds are made of sulfuric acid. This is the same stuff that's in car batteries and is very, very unpleasant stuff. It literally rains acid on Venus. And these clouds drift high up in an atmosphere that's made almost entirely of carbon dioxide. Carbon dioxide, as you've probably heard, is a greenhouse gas. That means that it is very, very good at trapping in heat from the sun, a bit like a planet-sized blanket. On Earth, sunlight comes in, warms up the surface of the Earth, and then the Earth radiates that heat away back into space, keeping us at a reasonably comfortable temperature. Our atmosphere traps a little bit of that heat, enough to keep us warm, but nothing too unpleasant. Yet. On Venus, sunlight comes in, warms the planet, but that heat can't escape because it is trapped by the thick carbon dioxide atmosphere, and the result is that Venus is hot. Really hot. A nice chilly day on Venus comes in at an astounding 460 degrees Celsius. Hotter than my oven, hot enough to melt some types of metal. On the bright side of all this though, it's so hot that when it does rain acid, that rain actually evaporates before it ever hits the ground. So that's nice. Now you might be standing there wondering, how do we know all of this? You can do a certain amount of observation from Earth using increasingly ingenious methods of telescope technology, but in addition to that, a lot of our knowledge of Venus comes from a number of probes and landers launched by NASA and the USSR in the second half of the 20th century. And it's astonishing, isn't it? Humans actually landed machines onto the surface of Venus. And in fact, this is the first planet that robotic probes ever landed on, with the Soviet-built Venera 7 probe landing there in December 1970. Now, none of the landers worked for more than an hour or so before failing, most likely because parts of them melted, but the fact that we even did that is a testament to humanity's desire to understand the universe around us. Radar mapping of Venus, performed by other spacecraft that have orbited the planet, particularly from a NASA spacecraft called Magellan, have also taught us that the surface of Venus is surprisingly smooth. In a moment, we're going to look at the Moon orbiting the Earth and see that its surface is covered in millions and millions of craters, whereas Venus, on the other hand, doesn't have very many craters at all. And why is this interesting? Well, craters are caused by rocks from space hitting the planet, and the longer that a surface has been exposed, the more craters there are going to be. Or similarly, the fewer the craters there are, then the younger the surface has to be. And so the small number of craters on the surface of Venus tells us that the surface of the planet is very young. In cosmic terms, that is. It's less than 500 million years old. So Venus is about 4.5 billion years old. So in the grand scheme of things, that's very recent. So something major must have happened in the very recent past to reshape the surface of Venus. Scientists still aren't really sure exactly what, but there are plenty of ideas that you might want to read about in your own time. Now we're going to move on to our next observational target, and to do that I want you to hold out your arm again and start from Venus and move your gaze about 2 full hand spans up above Venus, and there you should see 3 stars in a straight line running almost straight up and down in the sky. Again, they're not hard to spot. You've probably all heard of this one before. This is the very well known Belt of Orion. The constellation of Orion takes its name from the stories of ancient Greek mythology. Depending on the story, Orion was a great hunter or a great warrior of some kind. Finding the belt is pretty easy, but spotting the rest of Orion is surprisingly awkward for us down here in the southern hemisphere because he is a little bit upside down, so I'm going to let your imagination do most of the work. Holding out your hand again, but this time without spreading out your fingers, start from the belt and then 1 hand width on either side of the belt. You should see 2 stars. So that's 2 stars to the right and 2 stars to the left, each about a hand width away. Now, if you're needing a bit more guidance, of the 2 stars to the right, the one at the top should be a little bit reddish, and of the 2 stars to the left, the one at the bottom is very bright and whitish. And all of these stars together look a bit like an hourglass that's been tipped over onto its side. Now, to build Orion in your imagination, those 2 stars on the right hand side, those are his shoulders. And that red star I mentioned just then, that star is called Betelgeuse, often mispronounced as Betelgeuse, and that name loosely translates from Arabic as shoulder of Orion. And Orion's head is a little bit further across, and he's actually facing the direction of the horizon, almost like he's looking at Venus right now. Moving across from the shoulders, you can see the belt, and then continuing to the other side, those 2 stars on the left, those are his knees, and your imagination can fill in the rest. In darker skies, it is possible to see more stars near Orion's shoulders and head, and you can probably see a couple where you are anyway, so he's often drawn holding a shield in front of him and a sword above his head, but in most light-polluted cities, these stars are somewhat difficult to see at best. There are a lot of fascinating stars in this part of the sky, which we're going to cover in later episodes of this audio guide. This really is prime real estate of the night sky. But for now, I want to draw your attention back to Orion's belt. And if you look at the highest point of the belt, just off to the top left, you should see 3 more bright objects that appear to be stars. They're very closely aligned, and I say appear to be stars because the one in the middle is actually something called a nebula, which we will talk about another time. And above these 3 bright objects, you should see a couple more stars extending upwards. If you've followed all of these directions so far, you might see a bit of a different pattern than a person, and that is of a saucepan. Orion's belt forms the base of the pot, and then the stars at the top left and above, they form the handle. And this is a uniquely Australian and New Zealand interpretation. You probably won't find people from other countries calling it the saucepan, but there it is. A common misconception that visitors to the Scitech planetarium talk about is they mistake this pattern of stars as the so-called Big Dipper. The Big Dipper is a pattern of stars, similar in appearance to the saucepan, but much, much further to the north, meaning that it is very, very low on the northern horizon, and we can never really see it completely from Perth. If you live far up in the north of Western Australia, like up near Karratha or Kununurra for example, you will have a marginally better view of it, as it will be slightly higher up in the sky, especially over the next couple of months, but it still won't be great. So long story short, if you're looking at a pan-shaped pattern of stars, you're almost certainly looking at Orion and the saucepan, and not the Big Dipper. Last but certainly not least in our look at the sky this evening, there is the moon. I'm not going to tell you where it is, you should have no trouble finding it. Big, bright and beautiful, the moon is pretty captivating. And as I just said, one thing you'll notice straight away, the moon is bright, but give it a moment and your eyes will adjust. Something that isn't always obvious until somebody points it out to you is that the bright part of the moon always points in the direction of the sun. It sounds obvious, but check for yourself. You can see right now the moon is not fully lit up because it's not a full moon tonight, but the side that is illuminated is in the direction of the west, where the sun set not that long ago. That's what we're seeing when we look at the moon. The bright parts are the parts that are currently illuminated by the sun. In other words, it's daytime. The moon has a day and a night, just like the Earth does, and we see different amounts of that over the course of its orbit. And as we see different amounts of that illumination, we call that the phases of the moon. Right now, the current phase of the moon is what's called waxing gibbous. It sounds fancy, but waxing basically means it's getting brighter, and gibbous means it's more than halfway lit up. And what that means is tomorrow night you'll be able to see a little bit more of the moon lit up, and the next night even more, and then the next night, on Tuesday, April 7th, there will be a full moon. And interestingly, that's why Easter is next weekend. Easter has the awkward definition of being scheduled for the first Sunday after the first full moon after the 21st of March. I hope you followed along with that. Your homework, and I'm being serious about this, is to go outside at 7:30 each night for the next few nights and see where the moon is in the sky. Remember where it is each night? You might even want to make a simple map to help you out, or use some nearby trees or your house as a reference, because it's not until you actually go out and watch it every night that you realise something really interesting. The moon moves fast across the sky, really fast. And that's why I said at the start of this recording that if you can't use this on Saturday night, then this little section about the moon is not going to stay accurate for very long. As you look at the moon, you'll see that over its bright surface are some much darker areas, and these are called the Maria. Maria is an ancient Latin word for seas, because early astronomers speculated that these dark parts of the moon might indeed be exotic seas. And you might have heard of some of them, like the Sea of Tranquility or the Sea of Serenity. Apollo 11 landed in the Sea of Tranquility just over 50 years ago, and that's where Neil and Buzz took the first steps onto the lunar surface. Nowadays we know that these darker areas are actually ancient lava floodplains, where lava emerged from volcanic activity and filled up the basins of craters that were left behind by giant asteroid impacts. Even without binoculars or a telescope, you can see that the moon is absolutely covered in craters of all sizes, and these are most easily visible on the edge of the day-night line of the moon to the right-hand side. You'll see that that edge is not perfectly smooth, and that's because sunlight is dipping into craters and shining off mountain peaks, and that's great proof right there that the surface of the moon is not perfectly smooth. Here on Earth we have weather and wind and rain, so if the Earth gets hit by something that leaves a crater, then that crater will eventually wash away after a few million years, depending on how big it is. As we heard about on Venus, some sort of geological activity occurred a few 100 million years ago to resurface the planet, removing any old craters and giving it a new, smooth appearance. The moon, on the other hand, has no atmosphere and no weather, and these days, fairly minimal geological activity. And so that means if something impacts the moon and forms a crater, then that crater is going to stay there forever. And indeed, some of the craters on the surface of the moon are billions of years old. Some people like to make pictures with the surface of the moon, some of the features. I personally have never been able to make anything particularly interesting, but maybe you've heard of the man in the moon. Maybe you see if you can make a face in it. And if you figure out how, then let me know. The last thing I want you to do is to think of how big the moon is in the sky. It's enormous, isn't it? It's huge. It must cover a pretty decent percentage of the sky, right? Well, hold out your hand one last time. Close one eye and cover up the moon with the fingernail on your pinky. Could you do it? If not, then you might need to use your thumb, which is a little bit bigger, but the lesson here is that the moon is surprisingly small in our sky. Of course, that's just because it's far away, about 380,000 kilometres on average. In real life, it's quite big, It's about the size of Australia, actually. And I think that there seems like a pretty good place to end. If you could put Australia up into space as far away as the moon is, then they would appear to be about the same size, which is certainly pretty cool in my opinion. Thanks for listening, everybody. Tonight we learnt a little bit about the atmosphere and the geology of Venus, the stories of the stars in and around Orion, and a little bit about the phases and the surface features of the moon. We kept it pretty simple, but over time we're going to be adding a bit more detail about some more of these things. If you just can't wait, then you can definitely find more resources online. I personally recommend a series of YouTube videos called Crash Course Astronomy. Watching these is a great way to satiate that hunger for space learning. We'll see you on the next episode of the Audio Guide to the Galaxy. Good night, everybody.